I'd like to take the derivative of the function y equals f of x equals x to the fourth. And we're going to use the power rule so that we have the first derivative is going to be 4x cubed. The second derivative is going to be 12x squared. The third derivative is going to be 24x. And the fourth derivative is going to be 24. From there on out, the derivatives are all 0. Now, what I'd like to do is take the function f of x plus h, which we use in deriving the derivatives. And f of x plus h now is going to be 1x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus 1h to the fourth. Now, if you look at this number right here, 4x cubed, that's the derivative of f of x. We would normally subtract f of x, divide by h, and take the limit as h goes to 0, and that gets us this. Now, let's look at the coefficient of the h squared term, 6x squared. The second derivative is 12x squared. But if I take 6x squared and multiply it by 2, I get 12x squared. Let's look at 4x. The third derivative is 24x. But if I take 4x and multiply it by 3 factorial, I get 24x. Let's look at the 1. If the fourth derivative is 24, then I've got 1. But if I take 1 times 4 factorial, I get 24. So here are residing the first derivative, the second derivative, the third derivative, and the fourth derivative. Which sort of means that maybe later on in calculus, we can take a function and write it as the sum of its derivatives.